You humiliated you humiliated what that YouTuber, McToon? Holy smokes. I just got here. You're probably talking about that already a
Oh,
ton.
what's up, Reductio? What's up, man?
Yeah, like, cause and apologies if this is recapping. You already talked about it ad nauseum, but his calculation based on your numbers was a refraction coefficient of 0.3, but you said it would have to be 0.8. And then he just
Well,
started, it seemed like
yeah,
he rage quit. He started coping and then rage quit.
he didn't rage quit, but he started just screaming at me, calling me names and just and trying to
What
change the
was,
conversation, basically, just not addressing the problem and just spazzing out, basically.
Well, and I'll say this too. I think he wanted that 9 meters observation height to stick because that would lean more towards his point 0.3 K factor. And
Yeah,
the
that's
fact
how
that
he
it
came up with
wasn't, that
that.
was wrecking him.
Yeah, and it wouldn't even be possible to have a 0.3 refraction coefficient anyway, and even though their refraction coefficients just begging the question of a globe in the first place. It still would be impossible due to the meteorological conditions that India made sure he went there on a day where the water temperature and the air temperature was the same, so they couldn't use refraction as an excuse because the meteorological conditions weren't present for that to be a possible explanation. And then India also used infrared as well, infrared cameras, even further mitigating the refraction claim. That's why they had to try to focus on the observer height, and it's because they were putting the elevation marker on top of the roof of the pavilion hut thing that India was inside of. So it was telling you the height of the top of the roof of the gazebo thing. But if you use a proper elevation height website like the USGS one, it says exactly what India said: 15-foot observer height. So 15-foot observer height, that means the horizon should be about 4.7 miles away. But we could see the entire ship 10.6 miles away. And the ship was tracked at that exact time on tracking radar. And then the buoy, where he got the temperature of the air and the temperature of the water, was in between the camera and the ship, right in between. And the water was actually 45.9 degrees. And then the air was cooler. The air was 45 degrees. So it worked.
I got to ask Indio.
Yeah.
Go ahead. Go ahead. Finish your thought. I didn't know if you're. I was just saying I need to ask Indio if that was like a day or two after a storm. I'm curious about the conditions because I want to see if that lines up with my theory that like the best time to go and look is like 24 to 72 hours after a storm rolls through because everything clears up. Everything's all the particles are all on the ground because it was all either blown away or rain fell and dampened it back down. So I'm just curious. So what's up, Reductio? You a flat earther now?
Well, what was his ending position? I kind of was like groggy this morning, but when it ended, it seemed
never
like he
got to it.
changed his position or something about it. Like, where did he end up?
Well, not really. At the start, so he said that he said there was something in the observation that he thought that I didn't notice, and he said when he pans to the left, you can see a buoy that's beyond the ship, and it looks like it's partially obstructed behind the horizon. And he said that that's not possible on a flat Earth. That debunks the flat Earth because it's impossible to have bottom-up obstruction on a flat Earth. And that's when he kind of shot himself in the foot because that's when I said, well, you know what sinking refraction is. And then it turned out he did know what it was. And he explained, he defined it just fine. And I said, okay, so if you have the meteorological conditions, then can you have bottom-up obstruction on a flat surface? And he just kept going silent. It was like 15 seconds of awkward silence, and he just refused to answer the question over and over again. And then finally he admitted, he said, if the conditions are right, then yes, you can have bottom obstruction on a flat surface, because for the last 7 years he's been telling everyone that you can't have bottom obstruction on a flat surface.
It's actually really easy to do bottom-up obstruction on a flat surface.
It's the easiest thing to replicate out of all of the atmospheric effects.
Yeah, exactly. Because you need all the temperatures and the weather to be perfect for some of the other stuff. Bottom-up obstruction, you can do it over a short distance, and doesn't matter what the weather is too much.
Yeah, exactly. You just need a little bit warmer air up higher and a little bit cooler air down lower. Sorry, other way around.
Well, even just need a reflective surface. If you're on a reflective surface, bottom-up obstruction happens naturally. That's why I use my railroad tracks to do bottom-up obstruction. Because it's light reflecting off the rails, which is interfering with seeing the bottom of the object.
Rayleigh, you are a breath of fresh air when it comes to perspective and angular resolution.
Sorry to hear
You're
that.
so sound. Huh?
Sorry to hear that.
Why?
Because you're only saying it because it's true.
Well, I mean, why would I blow smoke up your ass? That's
I
like
know. I'm just joking.
all those years that you spent learning about, you know, graphics and 3D animation and everything like that. It's all paying off.
Yeah. I learned to use the railroads because I watched like 5 hours of physics videos on the Rayleigh criterion and different things, right, of the physics of light. And I just thought to myself for about 10 minutes and said, how can I duplicate this over a short distance? And I said, oh, I can use a railroad track. You know, if I could think of it, I'm curious why no one else has ever thought of this.
Anyway, to answer whoever asked if I'm a flat earther now, no. I mean, MC Toon said it once, but I don't think he hammered hard enough, because he could have just said, look, like, you didn't do a vertical gradient, and he could have just hammered that. And he said it once, but I don't know if the coefficient he calculated or what you guys calculated is accurate for that reason.
Oh, I just used the like the one that they always go to. It's Walter Bislin's one. It's the Advanced Earth Curve Calculator, they call it. It's like the bee's knees of the anti-flat Earth. Basically, it's got a refraction coefficient slider, and to have zero obstruction on that ship, you would have to have 0.76 refraction coefficient, which is like crazy extreme refraction. Like standard refractions, 0.13 to 0.17. So when you're getting up to 0.3 is considered crazy, like almost crazy refraction, where you would have really obvious miraging effects and things like that. Okay, but going up to like 0.7, 0.8, 0.9, that's where there's like so much refraction that like it's not meteorological. The meteorological conditions would have to be for that to happen.
That's going into the stupid realm of refraction.
Yeah, it's going into the realm that isn't anything that they could validate ever happens in reality, because we have limits to how.
I can prove to you.
Oh, here we go.
Earth is round.
Okay.
Did his mama not teach him any manners better? Like when somebody's talking, to wait until they're done talking?
Is he still here, or did he leave? Yeah, basically you would need so much refraction, that the Earth would just look pretty much flat anyway. So.
Yeah. And I get that same refraction on different days of the year and different weather conditions. How is that possible?
And they would need what they call downward refraction for that to work on a globe. So the light would have to be bending down. For the light to be bending down or deviating downward, you would have to have cooler temperatures down lower and then warmer temperatures up higher. But because we know that the water temperature was hotter than the air temperature, it's actually not possible for them to have that downward refraction that they would need for that to work on a globe. So yeah, Indio picked the perfect day. Go and do that.
And warm air over cold bodies of water typically create fog.
So wait, who is the guy who said he could prove the Earth is a globe?
I think he ran away. Yeah, because Ruhif, I had a conversation with Ruhif as well. Ruhif was saying the same thing. On modern day debate, he was debating against I forget who he was debating against, but he said it's impossible to have bottom up obstruction on a flat Earth. I think he might have said it can be possible, but you have to have a mirage. You have to have an inferior mirage, which requires you to have which is super obvious. He said it's super obvious when you have an inferior mirage because you have that crazy mirroring effect, which is true. And he said without that, it's impossible to have bottom-up obstruction on a flat surface. That's why when I saw him pop into the server, that's why I went and had a discussion with him but he was much better to talk to than McToon. He didn't spaz out, and he stayed calm, and then he ran away right when he got cornered. He said interesting, like Jaren, and then said he had to go. But he had no rebuttal, and he admitted that he has to do more research on sinking, and that because I showed him a whole bunch of like practical demonstrations of bottom-up obstruction on flat surfaces without any inferior mirage happening. Well, sinking is an inferior mirage, but it's like a super mild type where you don't have the mirroring effect.
Yeah, I don't think a glober has to take a position on that necessarily. Like it just seems unnecessary. But where did all this happen? How did you set that up? You said you stayed up till like 5 a.m. or something.
Oh no, yeah. I was just up like randomly because I was listening to the stream on YouTube, and McToon went into a guy named QOps Discord server where he does his shows. It's a flat Earth server, but it's just filled with like the obsessed anti-flat earthers, basically. All the people that are banned from our channels, basically. Yeah, like the real trolley type ones that just completely butthurt towards flat earthers. But anyway, McToon goes in there to do his show sometimes, and I was listening, and he was just acting like super cocky, arrogant shit. And he said a few things that I knew were incorrect, and that if I jumped in, that I could show him some stuff that would contradict the things that he was saying. So I decided, screw it, I'll just jump in and see how it goes. I knew that he would be bad faith. I've watched enough of his debates to know that he's not a good faith debater.
He's the guy who actually went to the South Pole, right?
Yeah,
or to the Antarctic.
He went to Antarctica. He's like the one that's responsible for most of the anti-flat Earth content out there. McToon is always like setting up this, setting up that, and people will be consulting with McToon, like Will Duffy. When Will Duffy would debate with someone, he would have McToon just feeding him information during the debates and things like that. Yeah, that's the guy in the side chat that Travis just put in.
Where's the guns, Nathan? What is this? What does that mean?
Yeah,
guns. Oh, because they say there's like armed military at the borders. Someone said that was like a meme from years ago.
Nathan Oakley said like 7 years ago or something like that you can get arrested if you go to Antarctica without a permit. And McToon was there with a permit saying where's the guns, like saying Nathan Oakley's wrong because he strawman Nathan Oakley and said that Nathan Oakley said you can't go to Antarctica, because Nathan Oakley did say it, but he meant you can't go there just freely. So McToon took that and said, I'm in Antarctica, where's the guns, Nathan? And now there's a whole bunch, it's like a meme now. There's a whole bunch of songs. People have made a bunch of songs with that that clip.
Yeah, there's been at least 2 people who showed up in Antarctica and got arrested.
Yeah, a Chinese pilot pretty recently. He took a
I
detour.
heard about that.
American Chinese pilot.
Oh, he was American Chinese, was he? Okay.
Ethan Gao. Yeah, Gao.
Oh,
And
his name was
Yarrow
Ethan. That's not very
Andohoy is
Chinese.
the Norwegian guy who got arrested.
Yeah.
One thing I found compelling about McToon, though, he said before he went to Antarctica, he predicted the angle that the shadows would be, and then when he went there, he actually measured it, and it lined up. So I was like, okay, like he has a model, he makes predictions. Model seems to be accurate. That's compelling.
Oh, well, the globe's created from the sky, so it's no surprise that the globe model matches up with the sky and with the angles of the celestials, because the globe was purely constructed from the celestial sphere, which is not an actual sphere in the sky, but it's an imaginary concept that the ancients, even before anyone was a flat earther, right? The ancients came up with what they called a convenient way to map out the sky, because they used the sky all sorts of different things, like navigation and for all sorts of when to plant, everything. So they needed a convenient way to map the sky out. So they came up with a convenient way to do that, and they called it the celestial sphere. So you imagine a big giant sphere in the sky, and then you draw that sphere, and then you say, okay, so when we're at this point on the Earth at this time, this particular constellation or this particular star is in this exact position on the imaginary celestial sphere, and that was a huge thing. People used to love the celestial sphere. If you look at the ancient statues from Atlas, okay, which now have a globe on his shoulders where he's carrying the globe. If you actually look, that was changed over time. What he actually had in all of the original sculptures was a celestial sphere. He's actually holding a celestial sphere. And then later on, people like Pythagoras and Plato and these Greek philosophers, okay, they took that idea of the celestial sphere and they applied their philosophical reasoning that because the sky is a perfect sphere and spheres are the most divine shape, they kind of worship spheres. They said, therefore, the earth must also be a sphere. Because why would the creator create the earth imperfect and spheres are perfect? Pythagoras is the first person, allegedly, to suggest that the earth could be a globe. And if you have a look into him, he wasn't like a man of logic or mathematician or anything like that, like he's portrayed at school. He was actually a mystic cult leader that worshipped numbers and thought the sky was like a big musical instrument and blah, blah, blah. Crazy stuff if you look into the Pythagorean cult. But later, people took the idea of these Pythagoreans and they used that celestial coordinate system and then they inverted it into the Earth itself. So they took the celestial sphere and they inverted it into a terrestrial sphere. And that's how the globe became a thing. And that's still to this day what we're using when you're looking at these maps, the Mercator projection, the AE projection, all of these different projections are all projections of this spherical coordinate system that originated from the celestial sphere. That's why the sky observations match up with the globe, because it was reverse engineered from the sky to the ground, not from the ground to the sky. It's not like people went out and proved that the Earth's a globe empirically. Okay, they assumed it based on inverting a celestial coordinate system into a terrestrial coordinate system. That's why the sky observations, that's why the globers are always pointing at the sky to prove the globe, because that's where the globe came from.
I didn't know any of that, but don't you think that these kinds of predictions would be, well, maybe not even impossible, but just like less likely. If the Earth wasn't a globe, like if you're using all this math involving a globe to do the prediction, and it does actually line up in the real world, you don't consider that evidence in favor, like even if it's a small amount of evidence?
Well, no, it's not really evidence. Okay, you've probably heard
Not
the term
proof either,
before.
right?
Not
To be
to
clear.
not. What's that?
Not even proof, right? Just like a
Yeah,
shred of
it's not even
tipping the
evidence.
scales.
It's actually completely circular reasoning. Okay, because if you look at what the spherical coordinate system is, if you look at the sky observations, that's all a globe is. And you've probably heard the term before, not to mistake the map with the territory. A map is a tool, right? And it's used for certain things, but mistaking the map for the territory, that's where you're going to run into problems. Okay, so I'm not sure exactly what you mean by like if you make assumptions about the way the sky works and then apply them to the Earth, I'm not sure exactly how that would validate that the Earth's a globe. Right, like
I'm more
you
so
know the
meant
Eratosthenes. You know the
if we bootstrap
Eratosthenes.
yeah, no, but
Go ahead.
yeah, if we bootstrap some assumption like a radius, like Aristophanes did, then can we make predictions that come true with it, or do those predictions not come true?
Well, only
So if we,
predict.
because if we,
You could use the okay. So if you take the celestial sphere and then you use the celestial sphere to make predictions, then of course that's going to work. But if you like, let's say we take the radius value, and then we go and apply that to the real world and say, okay, we're going to test. We're going to make a prediction using that radius value, okay, and see if it actually lines up with reality. That's where it doesn't ever line up with reality.
well, yeah, like I think what their long distance observations do is it's trying to show that, like, hey, if we did assume that this was the R value, that would be the geometric horizon, and then even factoring in whatever realistic refraction, that it doesn't line up, and that we see further. So, like, you would make a prediction that you can only see such and such far, but you see further, and so that seems like it would be evidence against it, right? So I would think like your view would be something like, okay, yeah, you can make some predictions come true and some don't. Like we see like too far sometimes or whatever. I know that's not like
Well,
accurate
all
language.
the time. Yeah, no, all the time
Yeah.
we see is too far. But look, this is the thing. I mean, like, how would if you're he's not making a prediction. He's just checking a model. He's using a computer model, and the computer model is going to tell you that the sun's going to be at X point in the sky at a certain time of the year, and that angle would create a certain shadow at that point. That's making a prediction based off the spherical coordinate system, right? Off the globe model. And then obviously it's going to work. Obviously it's going to check out. It's not like he had to go and check that. It's kind of circular reasoning.
Well, we've lined up like, you know, every eclipse that's going to happen for the next 1,000 years. Like we know exactly when all of them are going to occur. We do all of that with globe math, right?
No,
we don't use flat math for that.
Actually, well, this is the thing. Okay, so the eclipses are cyclical. They run in cycles. They're cyclical, and it's not a prediction. It's actually a post-diction, because you're just predicting what's going to happen because it's already happened over and over and over again. Now, even NASA they have refined it, but they use the Saros cycle, which was actually invented by ancient cultures that were flat earthers many thousands of years ago. The ancient Babylonians, I think it was. Okay, they used the Saros cycle, and you can even look that up, and that's still what is used. Like, they were able to perfectly predict eclipses. They were able to line up all of the ley lines with the constellations, the Great Pyramids, right? These were all created by flat earth cultures, the Great Pyramids, all of this stuff, all of these megalithic things that are aligned with the stars. So yeah, it's it's not really a globe proof. And once again, all of this is based off the celestial sphere, which is just an imaginary sphere in the sky. There isn't actually a terrestrial sphere. It was just due to the inverted, right, the as above, so below. That was their reasoning, because that was literally the reasoning they used. As above, so below. You've probably heard that. Okay, that's the celestial sphere inverted into a terrestrial sphere. So it's just based off the sky. That's what the let me read out what they did. Okay, because you've heard of the the equator and all of that sort of, right? That's all based off the sky. Let me just find this so I don't butcher it.
Well, it's based off where the sun is on the equinox, right?
Let me just bring it up quickly. But yeah, it's all based off observations of the celestials. Yeah. Let me bring up something a little more specific. All right, so long before the Earth was mathematically defined as a globe, ancient astronomers visualized the heavens as a perfect rotating sphere, with fixed stars attached to its inner surface. This was purely a geometric and observational construct. It was a model of appearance, not of substance. The Greeks, Egyptians, Babylonian, and early Indian astronomers all described the sky as a dome or sphere revolving around a stationary Earth. The observer was placed at the center of this celestial sphere. Okay, so the coordinate system was celestial, not terrestrial. So in this framework, astronomers introduced celestial coordinates to describe star positions, celestial latitude and longitude, later called declination and right ascension, were angular measurements projected onto the inner surface of a sphere.
Available today, sweet onion teriyaki. The Italian herbs and cheese.
Hey, Elijah, you hot
Elijah.
micing?
Sounds delicious.
But the summary of what you're saying is something like it can't, MC Toon's predictions or whatever you want to frame it as can't serve as evidence of a globe because, like, you can predict that on a flat model as well.
Well, what's a flat model? That's the thing, right? We're not claiming to.
That, you're saying these
usually
things were
when
used,
people. Well, usually what people
they were
do.
still used like on a flat, like when we thought it was flat as well. So you're saying it could work for either or. So it can't serve as evidence for one when it serves as evidence for both.
Well, you're using so it doesn't mean that the ground. It doesn't prove the ground is either. Okay, because you're just looking at the, like when you're talking about latitude, for example. Okay, it's looking at the sky and then working out where the ground position is of a star at a particular time, at a particular angle, right? And then making a map based off that sky coordinate system. It's not the other way around.
Can
So
I
you
add
don't
something
know.
to that, DJ?
Yeah, just really quickly. Right. So you could transfer that coordinates, like you could imagine the sky as something other than a celestial sphere. Okay, and let's say you imagined it as a celestial plane, right? Then it would be different. Go ahead, Sheepdog.
Yeah, I was just gonna say, the celestial sphere.
Yeah.
What's up,
Green pepper.
Elijah? You're hot micing.
Can someone mute Elijah?
Yes.
Oh, Flat Earth is getting muted. It's friendly fire.
But hey, I mean, that's how we take care of each other. I know. So think of it like this, Reductio. If the Earth was not underneath your feet, you would still be looking at the celestial sphere. Now, we're not making a claim that the stars go underneath you. It's just what it appears to look like from your perspective in the sky. But because the Earth is in the way, you don't know if the sky is going all the way around. And the only way that you can determine whether or not the Earth is flat or curving is to just go out and measure the surface of the Earth. The sky has nothing to do with it. Like the sky and the Earth are two independent.
I gotcha. From my reference point, because I know before the final experiment, there was like many proposals, right? Like that of potential models, but now like it seems like nobody in the flat Earth space has like a proposal. I think
Well,
MC
not
Toon was like saying
necessarily.
something along those lines, but
Well, this is what MC Toon does, right? He'll find the easily debunkable flat Earth arguments, the bad ones, which there's plenty of to choose from, and he'll find the people that subscribe to the Gleason map, and same with Simon Dan or Professor Dave, right? They'll take these arguments and they'll say this is what all of the flat earthers say is the map of the world, whereas in 24/7, dating all the way back to when I joined the server, okay, some people are pushing the AE map or the Gleason map, but people have always said that that map's useful, but that doesn't prove that that's real, right? Like you don't say that the map is the territory and that this particular map is a perfect flat Earth map of the world. While it might have some merit to it, the layout might be something along those lines. That's the argument I've always heard from people like Indio and that kind of thing. And they will always admit that it's a projection of the spherical coordinate system, and that the distances, when you start going out further from north, start to stretch out, right? So say you get a Gleason map, and then you put down a 10 centimeter distance out towards the south. Okay, that same 10 centimeter distance in the south at a certain distance into the north will just be 1 centimeter because it has a variable scale, right? But the globe earthers and many flat earthers, okay, they'll say that they don't know how that works, and they've been told by people like Eric DeBay and things like that, and Dave Weiss, that this is the map of the flat Earth, and they don't get told about the variable scale or anything like that. They don't get told that it's a globe projection. So there's a lot of bad arguments getting around with that, and that's good that the final experiment happened because it did help, even though it's still being pushed by countless amounts of flat earthers, unfortunately. They're having to say that the final experiment was fake because it is a problem for them, all right? Because they had a particular model where they had a specific, like a little sun and a moon that rotated between the tropics every 6 months. And on that particular model that they were pushing, right, like Jeranism that went to Antarctica, he was pushing this particular model as the flat Earth model. And that particular model got put to bed, it got put to rest, which is awesome. It's an awesome advance upgrade or whatever you want to call it, moving forward for flat Earth in a way that shitty model got put to rest. Okay, and then there's a bunch of coping flat earthers that is having to say it's all faked in a studio and things like that.
But do you think
would be cool?
Like, so if you were to, and this is kind of like it's a challenge, but it's also, I guess it is a challenge, like, because on any way you could configure the continents, whether you have to stretch them out a little bit to make travel in the south work, and then and then lining it up with, real flights that real people have taken for the time and like miles per hour and all of that. To make that work, traveling in the south on like many different flights, maybe you could get one, but then you have to get all of them configured just right, the continents, the position, the shape, all of that. And then from there to see if anything else still like is aligned, like, where you would expect the equinox to be, where's the equator on that configured at?
Yeah, exactly. But the equinox, right? The equator is, right, it's in the sky. And the distances are being calculated off globe projection. They're being calculated off this spherical coordinate system, right? We don't know that the exact distances, the actual distances, because there's no way to note them precisely. And they say that it's 69 miles per degree of latitude. Okay, but nobody's ever measured that to know that that's real. I think the longest, India was saying yesterday, the longest distance they've actually confirmed is 7 miles. Right, so they're basically using this particular coordinate system based off the sky and saying that it's reality, and then they're saying, look, these distances work on this presupposed coordinate system. It's circular reasoning. Okay, we would like to know what is the actual distance. It's almost impossible to know that.
But
if you look
surely you
into
could
it.
like try to reverse engineer the distance in some way to like explain travel in the south, right? That would be the goal, is to try to explain it on any kind of configuration. And it's frustrating that nobody is doing that. I mean, a glober is going to say that you can't do that on a flat model, right? So it would be,
Well, what? And then
it'll
we
be
would say,
interesting
what
to go
flat
into.
model? What flat model are they talking about? And then they'll pull out the Gleason, which
They'd have
is
to make
a
one.
globe.
No, I'm saying like make a new one. If somebody could make one that does explain.
How are you going to make it though? Like, so that make an actual map of the Earth, right? Because the ones that we have now are just projections of a spherical coordinate system, an imaginary way of envisioning how the sky works. Okay, these maps that we're using for these references aren't based off real world cartography where people have gone out and actually mapped out the surface step by step using methods like using boats and playing like boats and like the old fashioned methods they used to do to map out smaller areas. They're not going and actually mapping out the entire Earth physically. They're just projections of the coordinate system. So whatever distance it takes to get from this point to that point, right, it varies a lot. You'll find that they vary a ton by many hours over long distances over the ocean. There's all sorts of things to take into account, like jet streams and all sorts of things. Indio, if you talk to Indio or Yoda, or maybe some of the other guys in here that know more about that particular argument than me, that would probably serve you better. But
All I know about that is like it takes less jet fuel to travel one way than the other. It takes longer, more jet fuel because the jet stream.
Yeah. Well, did they go back? I
think we know about that.
They don't take the same route back. They don't go against the jet stream on the way back. I don't think they do that. They take a different route, don't they?
I'm not sure. But
if you're talking about like Sydney to Santiago or something like that, I think they.
But if you know the distance and then like approximately even how long it takes, and I know some of it's based off like you would say a projection. So like you wouldn't be relying on some stuff, but surely there would be a way to kind of even just attempt to explain travel in the south on any kind of flat map, model, whatever you name it. I've never seen an explanation, which is a red flag for me.
What an explanation for what specifically?
How it's even possible, because obviously on the Gleason map it's like 3 times as far, so it would be impossible. So there has to be some other.
Well, it's the same distance. It's the exact same distance on the Gleason map because it has a variable scale. So if you use the Gleason map for what it was intended for, and you use it correctly, then it's the exact same distance on the Gleason map than it is on the Mercator projection or the Peters projection or any other projection. Every single projection that we use is based off the celestial sphere. So any projection that you use will be the same spherical coordinate system distance from Sydney to Santiago. Right. Once again, it goes back into straw man. Well, okay. So I mean, the Earth could be flat, and we could still navigate using a spherical coordinate system. The ancients did that, right? That's like the ancient islanders, like the I forget exactly which country it was, Samoans and things like they navigated the Earth using the sky. They were flat earthers, right? The celestial sphere it was invented by flat earthers.
Doesn't a curve, though, I forget if it adds or subtracts distance, though? Like, isn't that a problem?
Well, there isn't any. Okay, well, there isn't any curve. So there's no evidence that there is any curve on the Earth in the first place.
Oh, okay. I understand what you're saying. You're saying everything now is just baked in already. That
is baked in.
It already does work. So okay.
It's like circular reasoning. It's like it's like it's making an assumption and then your calculation matches the assumption that you made.
So you're saying that if you actually did use like proper globe math, then you wouldn't be able to travel anywhere because like what we have now is like baked in flat math or like a flat plane. So
Well,
It
it's
wouldn't work
it's based in celestial sphere. It's like it's baked in ground positions, baked in sky observations matching up with certain GPs on the ground, that kind of thing. So it's not really.
But there's an objective amount of like miles in between any given A and B.
Yeah, look, that's an argument. I kind of like that argument, as well. It's like if you were to just say you were to get in a plane at Sydney and then you go to Santiago and it takes X amount of time to get there, and then you do it a whole bunch of times, you can kind of work out approximately how fast the plane should be flying and how long it takes and that kind of thing, and work out, okay, so it's not 200 kilometers away, obviously. It's not 500 kilometers away. Like you could start ruling out things and say, okay,
Yeah.
it's got to be approximately a certain distance away. And that is an interesting
That's kind of what I'm
argument.
getting at.
Yeah. But how accurate, like, how do we know the distance in the first place? How do we know the actual distance in the first place? I don't know. Look, Antonio, if you see Yoda or Indio in here, ask them that same question. They'll have a much better answer than me. I'm more like into refraction and long distance observations and stuff like that. I will look more into the coordinate system conversions and stuff soon. But there was a guy named Antonio Subarates, and from the UK. He passed away during COVID times, unfortunately. I think he had cancer or something like that. But he was a really smart guy, and he actually took he made his own map. He did make a flat Earth map. He spent a ton of time putting effort into it, and he was doing it the way that you're suggesting. He was using known shipping routes and things like that, and using the times that it took to get from point A to point B. And he actually constructed a big map. I've never heard anyone debunk his map. I'm not saying that his map's correct, but he did make a map, and I've not heard anyone debunk it. I know Indio and Yoda and other people, hold it in high regard and hold him in high regard. I can try to find it and post it in the side chat.
Oh yeah, if you could DM it to me, I'll have it. It won't get lost.
Yeah. The copies that I could find of it weren't that pretty looking, if you know what I mean. But I actually fed it into AI. I said, don't change it. I said, just make it look nicer. So I made some nicer looking versions of it. Okay, so yeah, I'll pop it in the side chat just in case anyone else listening wants to see it. All right, so this is the basic layout of the map here. Here it is in color. So yeah, that's also part of the problem. If flat earthers did give you a map, it's like, how would you actually check whether it's correct or not? It might be kind of difficult to do that.
I mean, you look to see if there's any flights from, I don't know, Chile or whatever, somewhere like to Australia, see how long that takes, and then measure here. If there's a scale, then
well, how are you going to come up with a
cross-reference.
scale? How are you going to make a scale? That's the problem. How are you going to make an accurate scale if you don't know the distances in the first place?
I mean, you'd have to like estimate it. You'd have to, like, with the plane thing you were talking about, or shipping routes, or even just driving yourself.
All right. There's always going to be a bunch of inconsistencies, and I mean, like, you know what I mean? Estimations, the word I was looking for. But yeah, I guess that's what he used, was estimations using shipping routes and all that sort of thing. I know Indio knows a ton more about how that map was made because he was friends with the guy, I think. So if you want to, I don't know if you're in my server, but I have a whole section that Yoda made called Antonio Subarates.
Give me a link to that server, and then this other one that MC Toon was in. I just want to see a shit show. If there's like often shit shows in there, I will like definitely enjoy.
Oh yeah, that's pretty much all.
What is it called?
The shit show server.
Yeah.
It's I'm not even sure.
Is
Anti-truth
it run by a
alive.
flat earther?
Yes. Some people say that he's not a flat earther, but yeah, he's run by a flat earther.
Is this
Right, so,
is the anti-truther one?
yeah, so his name's Q-Op. He's more into the like the ether arguments and trying to prove that the Antarctica trip was done in a studio and kind of thing. So
Wait, for real? Oh, okay.
yeah. And I'll just send you a link to my server. My server's like a big library, basically.
Yeah, do it.
If you want tons of information about refraction and that kind of thing, there's just everything, like all like globe history. It's huge library.
Why do
So I
people
sent
in
you
here
those.
lean against the studio hypothesis?
Because it's just, in my opinion, it's just a dumb argument. There's no compelling evidence for it at all, and there's footage of them landing there on a plane. There's marathons that take place there. There was footage of it before they even went there, of the 24-hour sun. 8K footage. There's footage of them riding bikes all around the camps. There's footage of them driving from point A to point B in snowmobiles, boarding the plane, unboarding off the plane. Everything matching up with other footage from the place. Weak arguments about it being faked, like why didn't they have foggy breath coming out? Because when it's cold, you have foggy breath, but that doesn't always happen. And Antarctica is like a desert, even though it's icy. It's dry. It doesn't rain there much. And even here in Poland, sometimes when it's negative 20 degrees, you won't have any foggy breath in winter at all. So that's a shit argument. And then other arguments like, they don't have footprints. Like you don't hear the snow crunching under their feet when they're walking around, and then you look on the ground and there's no footprints left. It's like, okay, but it doesn't snow there very often. And that snow that's been there has been frozen forever, like for countless amount of years, and it's compressed, and there's always heavy equipment driving around, and over time it's compressed. It's like ice. So it's not the same as when it starts snowing in your country and you walk through the fluffy snow and it's like making that noise. But in some places there was that noise. So yeah, that's another shitty argument. Then there's like some artifacts, and it looks like the sun's like a football shape and things like that. And that can just probably be some sort of camera byproduct of 360 camera or something like that. And then other people say there's like you can see these black lines up in the sky that makes it look like there's a studio. Like literally you zoom up into the sky and there's these right angle black lines, which turns out could just be another byproduct of using a 360 camera as well. People that use 360 cameras have said, yeah, they've seen that 360 footage. So it's just another weak argument. Hey, I'd be all on board for it if I'd think that was awesome. If someone could work out they faked that trip, I'd be the first person to be like, well, that's great. But yeah, I just
do you guys debate that guy, like, or does your group of flat earthers debate that group of flat earthers on some things like that, for example?
Not really. He's more than welcome to do his own research and try to debunk it. And if he can debunk it, then good on him, So, I mean, at the end of the day, NASA was able to fake the moon landings. Okay, this would probably be a hell of a lot easier to fake than the moon landings. So if people want to go and spend a ton of time doing research into it being faked, then I think that's beneficial, right? It's great to check things thoroughly, and to try to debate him against it. I mean, it's not really my goal is to debate. He'll work it out on his own, sure. He's new to flat Earth. He's only been a flat earther for 2 years, and I hear his arguments improving. And there's a whole bunch of things we do agree on. I even heard him say the other week he doesn't think it's faked anymore or something like that. I'm not sure if he went back on that, or he doesn't think it was done in a studio. I'm not sure.
Drama. It's
It's
interesting.
not well. They're really, yeah. I mean, you get drama among the globe side as well. You know, you had the geocentrism versus heliocentrism, and people getting locked up in jail and threatened to be killed and stuff like that for suggesting heliocentrism. I thought it was geocentrism, and then you've got people arguing over relativity and quantum gravity, and you know they have all of their own little shit shows going on. People are always going to argue about different things. But at the end of the day, you know, all the globe earthers all agree that the Earth is a globe, and all the flat earthers also all agree that it's not a globe, that it's a flat surface. So,
Gotcha.
yeah.
Well, I'm just building a computer right now, so it's good to have a nice chat. Is everyone here? No,
Yeah.
there's no like new faces that you want to talk to. I'm just gonna mute up.
Yeah, I got a stack of stuff to do anyway, but I appreciate the conversation as well. And yeah, if anyone has any questions, they can jump in and ask.
Oh, hello there, Mr. Brown Recluse.
What's up, fella?
How you doing, bro?
Swell.
Oh yeah, you've been here before. I think everybody's talked to you in here but me.
I haven't spoken to Brown Recluse.
I hear that you're a crowd favorite. Is that true?
I would be up to the crowd now, wouldn't it?
That is true. You're absolutely right. So what brings you in today?
I'm just always stopping in, seeing what you guys are up to.
Oh, for sure. Do you like us as a people?
Interested in, for sure.
Okay, fair enough. Fair enough.
Have you been around long, or is there a reason we haven't crossed paths before?
I am normally out on excursions at this time of the day, hopping into new servers, trying to see if I can set up like a new satellite area on a new server for 24/7 to see if anything works out.
Not there probing communities,
Yeah, pretty much.
doing the Lord's work.
Alien. Yeah, I'm into that. Yeah, how are you still stuck on your ball?
I just think it's a better answer for what we see out there than doesn't look like lasers bend, you know?
Wait, you said it doesn't look like lasers bend?
Yeah, it
And
doesn't
then
look
what
like
you see out there? What are you talking about? You see no curve ever in real life.
I mean, again, you guys, you know my stances. We don't have to go in a circle or a sphere. We don't gotta go in any of those, you know.
Well, I mean, I never talked to you before, to be fair. I don't really know your stance. That's why I was wondering, like, what keeps you on the ball?
The collection of
For me,
facts
anyway.
and the explanatory
Understood.
power of the globe Earth model, I think, is far superior to anything that a flat earther can provide.
Well, what explains the lack of curvature measured?
That's really hard to measure something really big.
Well, we know exactly how much the Earth curves because we know the exact size of it.
Right, but when we talk about measuring Earth curvature, really it boils down to shooting laser over water, right? That's what we're going to talk about when it comes to measuring.
Yeah, what's wrong with that?
Is that you're not measuring anything, you're just looking at a laser from far away. And the fact that
Well,
you
no,
can
we're,
see
we're
it.
measuring the deviation from the laser to the Earth to see
No,
if it
because
changes over distance.
on the receiver's point, so the laser's origin goes to the receiver on however far away. The receiver isn't measuring where that laser is actually, you know, relative to the Earth. They can just see the laser at the horizon.
You know
The
what I'm going to
observation is
do?
because you can see the laser at the horizon that it's not flat.
Yeah, not at the horizon. These
If-
laser examples are well beyond where the geometric horizon should be.
No, but regardless of what the geometric horizon should be, the laser is always observed at the very distant range of the observer's viewpoint. Like it's at the horizon
So-
relative to the observer.
So there is no geometric horizon then.
Okay, we can argue it all day and night.
No, I'm
right?
asking you the question. Is there a geometric horizon on the ball or not?
Oh shit, 1 second. I turned you way up right there. Again, there is a geometric horizon, but the apparent horizon obviously is not the same as the geometric horizon.
So we have
whether
two horizons. So the apparent horizon is beyond the geometric horizon. Is what you're saying.
AJ, we've talked. I was talking to Lats, man.
I don't think we have talked, but I'm just trying to
I
clarify.
guarantee
what
we
you're saying,
talked.
I'm just trying to clarify what you're saying here because it's a bit confusing, dude.
Well, obviously, there's if in a spherical globe or in a spherical model, there's a physical Earth where things are, but there's also refraction and atmospheric lensing. That means that things aren't always appearing where they actually are. So when we talk about the multiple horizons, quote unquote, it's that these optical illusions make it very easy to misrepresent what is and where it is.
So what you're saying in these laser examples is that the laser is going beyond the geometric horizon, but the observer is on the apparent horizon, which is beyond that geometric location.
No, what I'm saying is that the observer is looking at light originating from the laser, but the claim is that the laser itself, the origin of the laser, can be seen at any distance. The light created from a laser can be
No.
seen as far as the light can be projected.
The light from the laser is hitting a target on the opposite side.
No, it's not. It's being seen by a camera. Show me if you can show me it hitting a target. I'd like to see that, but it's not being hit by a target. It's being seen by a camera.
Yeah, Lats, have you got any of the FE core stuff?
Again, I've seen the
No.
FE core laser tests. It doesn't
Oh.
hit. It doesn't hit a target. The camera receives laser light.
Which would be the target.
Right, but again, what's the deviation?
Right.
What's the deviation? Obviously, the laser spread at
Right.
that point is enormous, right? So it's not that this laser is appearing, at the Earth's surface, right, and not the alleged 120 feet where it should be present. It's that this laser is spread over a very large distance, right, and the light can be received from the observer's perspective, however many miles away.
Well, I mean, what you could do, right, if you were to take like a laser, shine it horizontally across a frozen lake, you could just take a meter stick with you and just drag it along the frozen lake as you walk across and follow that laser.
Right, but as soon as you get whatever is 200 feet away, right, the laser isn't going to be clearly visible on your.
I'm not saying to get like a laser pointer that you buy off Amazon for like $1. You can get a pretty
I've
good
seen the
laser that
fancy
can shine
lasers that you
miles.
get. Right, I've seen the fancy lasers you get with the lenses that focus it down as much as humanly possible to get like an infinite focal length and yada yada. Right, it still doesn't mean that you can have a beam that doesn't converge after so many feet. Like it's still going to spread beyond a recognizable point over. Yeah, again, I know this exact video. Again, at 20 miles away, they're not. It's not hitting a target. Right?
Well, you
The
don't
light
even
is.
have to do it at 20 miles. You could just do it with 2 miles. You just measure at the first mile and you measure at the second mile.
Rick, can you show me it being measured at the second mile?
Well, this is what I'm
Yeah,
saying, that you can.
yeah.
Oh, sorry. Go ahead.
Oh, just there's plenty of footage of them actually hitting targets as well. And when you're using really, really expensive ones that have amazing collimators, over say 6 miles, 10 miles distance, the beams don't diverge very much at all.
All right.
You can see them.
If I could see it hitting a target from 6 miles away, I would like to see that. But because again, all the videos I've looked at have not shown that.
Yeah, well,
So
the ones where they're hitting the target, right? You mean hitting a physical target and you can see the actual beam on the target? Is that what you mean?
That's what you're referring to. Am I wrong?
Well, a camera is also a target.
He doesn't define that as hitting the target, DJ.
Well, we do have them seen. So we have side views of the laser. You can see the beam going the entire distance. You can see it not diverging over 6 miles distance. I've got an 8K image of a side view showing the laser going completely straight over a 6 mile distance. can see the beam going the entire way. So they took a very nice photograph using one of the best quality rectilinear lenses that you can use, right? So it stops the distortion, and you can see it's not bending around a globe or anything like that over the 6 miles. But you can see the beam the entire distance. How's that? Good or?
Again, I would purport that it is bending, right? So, but again, over 6 miles, what is the degrees of bend that you should see over a straight horizontal line? You know, quote unquote straight horizontal line.
Okay, so
How many degrees should it bend? Do you know how many?
I'm not sure.
You know
I'm not sure. I'm not sure degrees. How many degrees? But
it's like
it would be. It would be about a two. It would be about a two-story building, though. It would have to bend downwards over the surface of the Earth. Okay, if the Earth were a globe, but when you compress the image vertically, horizontally, because it's an 8K image, and it's done using a rectilinear lens. When you compress it, it doesn't bend downwards. In fact, it bends up a tiny little bit because the meteorological conditions make way that you would have a little bit of upward refraction, not downward refraction. So it completely debunks the globe, because for it to hit the target from 3 foot height to 3 foot height, it would have to be bending downward. It would be impossible for it to have upward refraction and for it to still hit the target.
How would it have upward refraction hit the target on a flat plane? I don't think that completely debunks.
It's just the tiniest little bit of upward refraction.
Again, I don't know specifically the thing you're referring to.
Yeah,
so
I'm just looking it up right. Right. So this is the raw NEF image as well. It's like a 50 megabyte image. So I'll link it. Right. This is from Lanolin. So this is from the documentary called "The Abomination of Desolation," where he goes and he sets up weather stations. Lanolin, very smart guy. He lives in Alaska. This is over a frozen lake in Alaska. Extremely cool documentary. He spent about $40,000 setting up the equipment for the test. He's got weather stations. He's got different spectrum lasers, and then he sets up the third station so he can do the side view of the laser traveling over the distance. Yeah. So I'll just post the link in the side chat to the NEF image. And in the FE core test, they do show some lasers hitting the target. Like they've got a big plastic target that's got lines on it, and you can actually see the beam hitting a particular point.
That's the test right in front of. I've seen that part of the video. That test is like right.
I'm not sure of the distance. Well, there's
it's right in front. It's like a test. It's the test zone right in front of the laser, so that they can make sure it's at a certain level.
It's diverged out quite a lot, and you can see the beam coming from a really long distance away. I know the one that you're talking about that's in the documentary where they do the test, just trying to align it from a really close distance. That's not the one that I'm talking about. Yeah, because you can see the beam coming from the opposite side of the lake. And it's a green beam, and it's hitting the target. I'll look that up in a second because I don't know the exact distance for that one. But 1 second, where are we? English Hub. All right, side chat. Here's the side view image here. So when he set up the weather stations, he calculated that the temperatures down lower to the ground were very, very slightly warmer than the temperatures up a bit higher.
Yeah, it definitely looks like it has an upward angle for sure. It's touching the ground on the right and not touching the ground on the left, obviously.
Yeah, I've got some squished
I can zoom in and see that it doesn't seem to be exactly horizontal. Definitely seems to be.
But you can see it doesn't diverge much. That was the thing that you were talking about.
No, it does look like a pretty converged laser for sure.
Yeah, he specifically bought one that had a particular rate of divergence over a certain distance.
Well, again, I'll admit that it looks straight, but again, so does the ground, right?
Yeah, it is. It's flat.
Right. It is level. That's for sure.
It's a frozen lake in Alaska.
Yeah. No, absolutely.
I have a bunch more information about it, but my folders are out of control now, and I need to go through them and sort it all out.
Yeah. No, again.
All right. Oh, here.
Go ahead.
Go ahead. No, you.
I was gonna say it looks flat. Again, I admit it looks flat, but again, so does the Earth. So
Yeah.
from our perspective, everything looks flat for the most part.
I don't know, but we would have byproducts of the curvature, which would be geometric horizon. We would have the obstruction of things in the distance.
So I mean, obviously, we do have obstructions of things in the distance, right? So the question is like, is it obstructed to the degree that it would be on a purported globe Earth, right? Obviously, you can see mountains far away and yada yada, and zoom back in on boats that have gone over the horizon, but it seems
well,
like
not really. I mean, that's a bad flat Earth argument. If anyone claims that you can watch a boat disappear bottom up and then you can zoom in and see it again, right? They're just parroting some bad argument that they heard somewhere else. There's
I've heard
not a
that
single
several times in here, dude.
There's no, because what you would hear people saying generally would be that the boat will disappear and then you can bring the boat back to view again. But not most of the time. What happens is the boat disappears because of the angular size becoming too small to resolve, and then you can zoom in and you can see the whole boat again unobstructed. But the only time a boat will appear to disappear from the bottom up is if you're low to the ground and you have ocean swells, or if you have sinking refraction or an inferior mirage. Other than that, they just disappear due to angular size.
Coastlines and mountains viewed from across large bodies of water can definitely be seen with the bottom occluded.
Right, but yeah, it can happen, but you need to take in the potential variables. Exactly. So we can do the same thing on a small scale on a flat surface as well.
Right, but it doesn't happen sometimes. It doesn't happen purely due to inferior mirages. It happens the vast majority of times that these vast distances covered, obscure specifically the bottom section of these large structures, be it buildings or mountains.
Well, like what? Give me an example.
Well, I can pull up several videos, but again, like, the Mount Fuji, I believe it was, like whatever the longest distance photo was of it wasn't Kilimanjaro. I forget the name of the mountain, but it might be Canada. It was a K1.
Yeah, but you'll find that the tip of the mountain should have been completely like way below the curvature of the Earth, and we can see way further than we should be able to see on a globe. Now you do have.
I don't think that's the case. I think you're mistaken.
All right,
unless we're talking about different images, but regardless.
All right, so this is all the globe side it would have to do, right? They would have to account for the potential variables that could cause that to happen, and then they can exclude those, and then they could say. They could do the mathematics, right? Then you could account for the refraction by measuring it, not by guessing. And then you could say this matches the globe. And then you could repeat it, and then you could have a bunch of awesome evidence like we have, and then you could have an argument for the globe. But that doesn't exist.
Well, there's a lot of observations that obviously match with a globe Earth, right? So, but when we're talking about specifically long distance observation, like any, you're saying there's no.
I just asked you for one, Brian.
Well, again, you can look at the rotation of the stars and the fact that there's a gradient of atmosphere.
That's different. So that would just be making assumptions, looking at the sky, and then making assumptions about the sky. So the globe, I did go over this earlier.
Okay.
Yeah, but you just looking at something that's not the Earth. Okay, I'm talking about actually trying to validate the actual Earth curvature, not making assumptions about the sky.
Right. So I don't think that that's fair to say, because again, the Earth obviously exists in a relationship to the sky in some way, shape, or form. I think we can agree to that.
Well, the sky is above the surface of the Earth. Okay.
Right, but the clouds are above the. Wait, but the clouds are above us, and we still live in a relation to the clouds. Like studying the clouds can absolutely tell you stuff about how we act, and like when it rains,
can they tell you anything? But can the clouds tell you anything about the shape of the Earth?
There could be evidences. They're not exactly great evidences for the shape of the Earth, no, but like it'd be part of like the atmospheric conditions and the great weather cycles and yada yada. So like, it has to do with water cycles and planets and the energy we get from the sun. So like I can include it in a much larger, globe Earth model, but it's not really evidence in and of itself.
Yeah, it would be kind of sucky point, just this is what the globe claims, therefore it's a globe.
Right. So, but like, I think we can agree that like observations made on the stars, right, are far less reliable when closer to the Earth, right? Like, when navigating celestially, like with sextants and whatnot, they generally don't rely on things within a certain degree of the horizon because they're generally unreliable as compared to the stars above, right? So like that alone makes it very difficult to use the horizon and like our observations of the horizon and long distant objects to make specific claims because of how much distortion and issues are with our specific observations of the horizon in general. So, and the stars have to go ahead.
Well, this is the problem. Then I would ask you, because you use the word horizon a lot. Now, I would have to ask you what the horizon would have to be if the Earth's a globe. Okay, and on a globe, the horizon would have to be a byproduct of the Earth curvature. Okay,
Well,
but in reality,
the sky meets the ground, right? So,
well, not necessarily. Like that's oversimplifying. Okay, so the actual definition is the apparent location where the sky and the ground meet. Apparent is always in the horizon definition because it changes all the time. But this is the thing. This is the thing. This is the thing, though. The bottom-up obstruction claims. Okay. Whoa. What the hell?
That's a noise. That's a noise.
One second. Yeah. So look, this is the thing. Okay, on a globe, the horizon would have to be, right, the physical geometric horizon. It would have to be a byproduct of the curvature of the Earth, and there should be a physical geometric horizon at a certain distance, depending on the height of the observer. That would have to be there physically, geometrically, if the Earth were a globe. And we can calculate how far that should be. Okay, and that's what a horizon is on the globe. So when you say something's obstructed behind the horizon, you're talking about a physical geometric horizon. Now, I would say that you don't have any evidence that such a thing exists in the first place to be using the word horizon in that sense.
But you talked about bottom-up occlusions, and I think you kind of trailed off on that first part after that weird noise came in. But like you said, that those is not evidence.
Oh, exactly. It's not evidence because we can just so we could just use the mainstream experts in optics, in refraction, and we could look up right now on like we could go just straight to Google and just type in what is sinking refraction, and it's going to come back with an answer that says sinking refraction, right, will cause objects on the horizon that would normally be completely visible, right, to appear like they're hidden behind the horizon or sinking behind the horizon, even though the geometric line of sight is completely unobstructed. Okay, that's what sinking refraction is referring to. Okay, so
is it your claim that sinking refraction is the case why things appear to be disappearing bottom up all of the time?
No, not all of the time. Sometimes it's because of physical obstruction, right? Like ocean swells are super common in the ocean. And when we see the very small amount of footage that we have on YouTube of ships disappearing bottom up, okay, most of the time it's a cherry-picked image that's at a heavy zoom with obvious choppy conditions and obvious large waves and unknown observer heights. And then we also have unknown distances, and then we have unknown meteorological conditions as well. And if you wanted to make the specific claim, you would have to count out physical obstruction, and then you would also have to count out the sinking refraction. These are both things that literally, by the definition, would cause exactly what we're seeing off in the distance. And we even have footage where it looks like, say, in the morning. Okay, so this guy, he goes to the beach in the morning, super clear day. He sets up his camera early in the morning, okay, when the water temperature is still a bit warmer than the air temperature, because during the night, the air temperature gets colder, the water temperature doesn't change. So in the morning, it's quite common for the water to be warmer than the air above it. So in the morning, he's got the conditions that would be
With proof, I'm Satana. The Earth is flat.
Put yourself on mute, dude. All right, so in the morning, okay, we see what matches the definition of sinking refraction. So there's a giant boat 14 miles away on the horizon, and you can't see the whole bottom of the boat's completely missing. And you can just see the top of the boat sticking out from behind the horizon, and he actually stays there. As the day goes on, he stays there for the next 3 or 4 hours, and he keeps zooming in on the boat and filming it. Now, what you see happen over the next 3 hours is that more and more of the boat starts to become visible. It's an anchored boat. And so 3 hours later, once the air temperature warms up and gets warmer than the water temperature, the sinking effect goes away, and you can see more and more of the boat. And then 3 hours later, you can see the entire boat 14 miles away. Zero obstruction, showing you that it matches up. It aligns with what should happen according to the meteorological conditions and the refractive conditions, according to the mainstream explanations of how those things would work. So these are things that need to be taken into consideration when making claims.
I agree. And I think we can both agree it's incredibly difficult to have all of the factors, especially when it comes to complex, refraction indexes and just atmospheric lensing across the board and just peering through any mass of objects. So again, having all the factors is next to impossible. So we have to come with our best, use the best information possible, right? So, and from what I understand, the combination of refraction, atmospheric lensing, as well as just the effects of air and water at the horizon level and at the surface of the Earth makes these observations generally unreliable, right? So using that as the one and only best evidence for there being a flat Earth is, in my opinion, short-sighted, when there's a billion other facts that make it far more possible that the Earth is not flat, and rather makes it pretty dang impossible to truly reconcile with a flat Earth model, quote unquote. So that's kind of why I don't like the laser test being the be-all end-all of what is and is not flat.
Okay, so it would actually be a completely outrageous claim if what you just said was a reason to dismiss the long-distance observations, and I'll explain why. Okay, just in relation to the laser tests, right? We're hitting the target every time. So, right, the amount of refraction that would have to be present in all of these completely different locations, in different places all over the Earth, using completely different weather conditions, okay, to have this extreme amount of refraction that would somehow perfectly guide the laser around hundreds of feet of Earth curvature, right? To hit that. No, I'm gonna finish. Right, I'm just getting started. I'll let you completely finish.
That's fair. No, totally fair. Sorry, go ahead.
Yeah. Okay, so we're hitting the target. Right. So to claim that somehow the laser is perfectly bending around the curvature of the Earth, right, to hit the target, or to be observed by the camera, which is the target, at point B. Okay, that's a crazy claim. Now, also, if you actually study refraction and you learn a bit more about it, you're going to realize that certain meteorological conditions have to be present for that type of refraction that you're claiming exists to occur. We can easily count that out, right? For example, the refractive index, right? It's the vertical refractive index that you have to take into account. Okay, and that's controlled by temperature. Refraction is controlled by temperature at lower altitudes, completely dominated by temperature, according to all of the citations of atmospheric refraction. Now, if you have cooler air down lower and warmer air up higher, then the light will deviate downward, okay? And that will cause looming, and that's the type of refraction you would need to say that this observation could work on a globe. Okay, and then sometimes we can have an inverted refractive index gradient. So that would mean when we have the opposite, we would have warmer air down lower and then cooler air up higher. Okay, that's common to happen. I mean, that happens every time we have warmer water and cooler air above it. So if we have that situation, okay, and just say we have 45-degree air temperature, right, and we have 46-degree water. Okay, but we can see something that is in the distance that should be hidden by, say, 20 feet. of Earth curvature or something like that, like a 2-story building. Okay, that would require a large amount of downward refraction to work on a globe. But it would be impossible to have that downward refraction if we have an inverted temperature gradient, an inverted refractive index. It would be meteorologically impossible to have that. Right? So we have great observations that have been done where we know the exact temperature of the water and the exact temperature of the air by having an official government buoy in the water between the 2 points over the observation. And then we could also use an infrared camera to mitigate even further the effects of refraction. So, for example, Indio 007, he went to the beach, he picked a day that he knew the water temperature was going to be warmer than the air temperature, and that he had a buoy in between the observation point, and he used ship tracking to track a boat that was 10.6 miles out. Okay, he set his camera up at 15-foot height, quite a bit above the surface of the water. Okay, and he could observe the ship 10.6 miles away with zero obstruction. On a globe, the geometric horizon should have been at about 4.7 miles, and that's the maximum distance you should be able to see the water, the surface of the water. That's where the horizon line should be. And the bottom of the ship should had 2 stories missing, right? 20 feet, something like that. Now, because he took into account the vertical gradient, or he discounted the option that the crazy amount of downward refraction to make that work on a globe would be impossible, right? He mitigated, right? He was able to count out that as an excuse. You can't use refraction as an excuse for that, right? That observation debunks the globe.
Right. So what I was going to say previously is that while obviously refraction has a part to play in, again, why we can see these lasers and why Indio could see the ship from far away and, through the, quote unquote, apparent geometric horizon that's supposed to be obstructing it, right, is that light isn't merely refracted, when it travels through the atmosphere. It refracts, it scatters, it desorbs, it absorbs, diffracts. Like it does all of these in a single moment, and it is not truly just bending down towards the observer. It bends in all directions essentially because it's hitting a bunch of different particles and refracting all over the place, right? So like when we looked at the laser, the horizontal view of the laser from previously, like obviously that's a very precise and narrow laser, right? But the camera isn't directly on the left-hand side, right? If you were to go 20 miles away, right, that laser is not, maintained at that distance, right? So like it's I still have yet to see any laser hitting a target that's not a camera, right? So, but everything that I've seen, the light
just went
scatters.
full fucking reset, didn't you, Brian?
No, I listened to every word that you said. Again, the unobstructed view from India from 15 feet away of the ship, right? Tracked it. Again, but the point was that refraction can't account for that. I'm saying it's not just refraction that's the issue. It's that light is not merely refracted. It's refracted, scattered, absorbs, and diffused, right? Which means that light, right, is not just going in a straight line. It can be seen from multiple different places, right? Which makes it far more easy to understand how it can reach you on a curved surface, right? But like I said earlier, I don't think that these surface level observations should be the be all end all of how we decide what the shape
demonstration do you have to back up anything you're saying, Brian?
That light is diffracted and absorbed throughout the atmosphere and not simply refracted? Because that was my claim. What other claim did you want me to back up?
Yeah, no, that light is continuously bending downwards towards a target.
No, my claim was that it's refracted, diffused, absorbed.
What demonstration of that do you have at all, except for word salad?
How again? I'll show you. I'll give you some papers on how light works. But again, that's the simple understanding of how light interacts.
Demonstrations.
Wait,
demonstrations. Same way DJ gave you a demonstration of a laser remaining collimated across, like, what was it, 10 miles?
6 miles.
And slightly refracting upwards. He gave you a demonstration. What do you have in the same manner demonstrating what you're claiming?
I can show you a demonstration of light scattering and light being diffused.
We know light scatters. We know light scatters.
Right, so that's my claim.
Continuously bending downwards, so random scattering is not continuous bending downwards.
But what direction does it scatter in?
All
So when
directions.
exactly. So when light hits a particle, it scatters in all directions, right? What happens when it hits the next particle and the next particle and the next particle? What happens?
It's not
It
how it
That's what
works.
you're saying.
continuously,
It's just,
it
it's just
continuously scatters
continuously
in all
scattering
directions.
downwards.
It
Yeah,
continuously
so
scatters in
look,
all directions, which means it does continuously
no,
scatter downwards.
no. Light will generally, it will, even though there's some scattering around, it will deviate towards the denser medium. That's what refraction is. That's what atmospheric refraction is. Okay, it's when an electromagnetic wave deviates towards the higher optically dense portion of a medium. Okay, so if you have, if that's what atmospheric refraction is. Okay, so
Right.
yeah, so if you have optically dense air higher, then the light's going to deviate towards that, and it's going to cause what they call looming, or it can cause a superior mirage or a fata morgana, depending on depending on a bunch of different factors. Now, if you have the opposite of that, we'll do the opposite thing. We have the opposite of looming, which is called sinking. We have the opposite of superior mirage, which is called an inferior mirage. So that's what happens. It doesn't just scatter everywhere. That's why we have these terms. This is what the
scatters everywhere. I said it does all of these things simultaneously. That's the
right.
claim.
But if we have pretty much a uniform gradient, a uniform temperature gradient, then you can't say that the reason that we can see the boat 10 miles away unobstructed is because of refraction, because the type of refraction on a globe that would require that is not possible in those meteorological conditions. It's impossible. You don't have the setup. It's like you don't have the parts to build the scene.
Right, but I specifically refuted the fact that the refraction was the sole reason that you could see the ship.
Okay, what's the other reason?
Again,
what's the other reason?
The light isn't merely refracted in one direction, like you're claiming, to bend down towards the observer. Is that this light, right, is refracted and scattered, right? So that this atmospheric lensing, right? If we look up atmospheric lensing, right, means that these objects, right, appear, right, in different places, and they're viewed, or they can be viewed, right, from much different places. So it's not merely refraction.
Get the definition of atmospheric lensing for us, and explain how atmospheric lensing could make a ship be visible at 10 miles that should be hidden by 20 feet at the bottom of the ship. That's not what atmospheric lensing is. So can you even define atmospheric lensing right now? What do you even think that is? Like, what do you think atmospheric lensing does? Do you think that's like atmospheric magnification? Or what?
It's a distortion of light caused by layers of having different temperatures. Is this definition at the very least?
Where is this definition from? Can you post it? Like a link to the definition?
Spacecenter.nz. This is one I already visited. You read it with me.
So even your atmospheric lensing, AI butchers refraction terms. It butchers these terms all the time. I know that's where you got it from, because I just typed it into Google as well and got the same thing as you. Okay, so what this is showing is atmospheric refraction, not atmospheric lensing. Okay, these AIs are completely retarded sometimes, and if you question it on it, it will apologize to you and get it right eventually. But what it's saying here is that light refracts, bends when moving through air of differing densities, always bending towards cooler, denser air. It says that when I typed in what is atmospheric lensing. Okay, this is straight from Google. Right, so it says always bending towards colder, denser air. Right, so if the denser air is above the warmer air, it's impossible to have the whole ship visible at 10.6 miles away.
Again, that may be true. Again, from what I'm looking at, that I was wrong on the atmospheric lensing. I was quoting a video that I apparently was wrong as well. So either way,
no, it's all good, man.
Either way, what I was saying earlier is that these surface level observations are obviously unreliable, right? To some degree.
No, Well, they're unreliable for a globe because
For a
the
globe,
globe
at the
side.
very least, I can agree to that.
Well, because the globe side has to make hyper-specific claims, and we're not doing that. We can't find the curvature, and it's just a default position. It's just a default position that if you have a surface area that doesn't have any curvature, it's just by default flat. I mean, that's not our fault. It's just the default.
I understand that that's your position. I just think that it makes far more sense that it's very difficult to measure that to measure this slight curvature over even vast distances.
It's not a slight. Well, it's not a slight curvature. It's a huge amount of curvature. Like I can show you an observation that shows zero curvature over a 21-mile lake. That would have to have 293 foot of curvature. That's a skyscraper worth of curvature.
We're going again. This is again lasers over lake, and again,
It's not a laser. It's not a laser. Well, it's not a laser.
Sorry, what are you talking about then?
Right, so it's an observation that was repeated. Okay, so it was done during the daytime, and it was also done during the nighttime, and it shows identical, crystal clear, well, not crystal clear because you're looking through 21 miles, but extremely clear conditions where we don't see any curvature, we don't see any miraging effects.
But what are you looking at? What are you seeing over 21 miles?
Yeah, I'll show you. All right, so I'm going to post some things in the side chat, so check it out. So the first one. This is the location. So it's at a place called the Great Salt Lake in Utah, and it's a good place for observations because it's like a dry atmosphere. So you can see much further. You don't have that haze to worry about as much. So anyway, he sets his camera up. So if you can see that image, you can see a yellow line. That's the distance markation tool. And he's got his camera set up on that little peninsula at the top of the yellow line. And then the target is just the shoreline, right? This shoreline that you can see in this next picture. So he's got a friend over on the other side of the lake taking some footage. Okay, so this is what it looks like. This is where he's going to be zooming into. This shoreline's 21 miles from the camera that I'm about to post now. So this is the camera setup on the tripod at the top of that yellow line. And he's going to be zooming across to the image above that shoreline there. So here's just a small clip. Okay, this is out of a high definition video, but this is just a small clip of that video. Right, so he's going to zoom from that camera over to that shoreline that you can see above, and the physical geometric horizon. Okay, not taking any refraction into account, just the raw geometry on a globe. The physical geometric horizon would have to be at 2.73 miles, right? But we don't see any horizon over the whole 21-mile distance at all. We just see shoreline to shoreline. Now, one more time, I'm just going to... All right, so I'm going to just post some comparison images. Okay, so once again, here's the close-up. And now, directly under the close-up, we're going to put the image from 21 miles away. Okay, so that's the close-up. That's the same shoreline you can see from 21 miles away, and the same white tower in the background. And then he stays there, and he does it again at nighttime. And at nighttime, once again, we can see the entirety of the what.
Respectfully, I agree that we can see far and that it does look flat. I 100% agree that it's relatively inconsistent with how a globe Earth model should be, at least to my understanding. I've always conceded that it looks flat. It always looks flat. I agree with that. It just A, I have to go. So, but B, I will continue this when I have a minute. B,
no worries, man.
What I have the most issue with is if this is the only thing that we use, right? Then and we dismiss all the other facts like the celestial bodies and the rotation of the stars and the atmosphere, the gradient, the alleged container, like all these things. If these are non-points anymore and that all that matters is that curvature can't be measured, then it just it leaves no conversation for anything else. That's my only issue. But I do agree. It looks flat. I don't really have any contention or not rather retort to anything that you've brought up currently.
All right.
So, but I do have to go. This has been pleasant. Thank you very much, DJ.
All right. Catch you next time.
Yes, sir. Adios.